Hello, my name is Gary Promhouse. There are many problems with our current transportation system, which we call CUTS. CUTS performs extremely poorly in virtually every major metric in the only significant transportation system function of providing trips that move people and goods between locations accessible through the transportation system network. This video specifies a new transportation system, or NETS, which performs better, mostly much better, in all those metrics using only currently existing technologies. We divide the TS metrics, or measures of how well a TS performs, into the four areas of safety, trip times, costs, and environmental impacts. In this video set, it is shown that CUTS is extremely unsafe, while NETS is designed to virtually eliminate all vehicle, and vehicle third-party, like pedestrians, cyclists, animals, or CUTS vehicles, collisions. NETS uses two modes, illustrated in our banner here, to replace all CUTS, roads, and rail trips within a landmass. The one which accounts for most trip kilometers we call WAN, standing for Wide Area Network. WAN vehicles move suspended below elevated, covered, and tracked guideways that have only 3D expressway-like crossings or intersections. These characteristics enable easy automation. The result is an elimination of all collision causes for WAN travel. These WAN features are enabled by using vehicles sized to carry two large adults comfortably, or a set of NETS reusable boxes of less mass that fit in the same space. As with CUTS, groups that do not fit in a single vehicle use as many as needed. These behave as a single large virtual vehicle by having visual communications available between associated vehicles. We use LAN, standing for Local Area Network, for the mode that can provide the short first and last legs to get cargo to or from the WAN network. When the cargo is passengers may choose to walk rather than use LAN. LAN lives here at ground level with all pedestrians, cyclists, and pets. LAN vehicles mostly travel at about the speed of human cyclists. The combined mass of a LAN vehicle and its cargo is seldom more than that of a big US football player. The vehicles are aware of any object moving anywhere on their path, even around corners. They use this information and their low speed, mass, and kinetic energy to ensure that no potential collisions turn into actual collisions. CUTS passenger trips are very slow, with inconsistent times, especially rush hour delays. NETS door-to-door trip times are always less than CUTS, and often would take less than 25% of the time. For passengers, the time between a trip request and being in a WAN vehicle would seldom be more than 1 minute inside settlements. Like CUTS high-speed trains, the tracked and physically isolated WAN guideways with no 2D crossings or intersections eliminate the two main reasons CUTS road vehicles are so slow in operation: stops required at 2D crossings and safety-motivated low speed limits. The NETS trip times are also consistent to within a few percent. WAN then exploits multiple tracks with staged speeds and low energy consumption rates to allow high speeds on all its guideways. As with safety, these characteristics are enabled by the small size and mass of fully loaded WAN vehicles. The main constraints on speeds are passenger comfort and the energy and power needs that grow rapidly with vehicle speed. The high-speed tracks for most of the highlighted streets in this image of Toronto, Ontario, Canada would be about 180 km per hour. This is also the case for all roads shown in this map of the central Ontario area around Toronto, with the exception of the red intercity lines that mostly run along CUTS expressway rights-of-way. All those would have associated guideways with top speed tracks in the 450 km per hour range. The guideways indicated on this view of North America would form such a high-speed on-demand network. CUTS is very expensive while NETS is very cheap. Average annual per capita expenditures on CUTS in the US are over $7,000. This is split between personal expenditures, typically on personal vehicles, government expenditures, mostly on roads and mass transit support, and embedded goods costs from shipping. Personal expenditures are dominated by the cost to own, maintain, and operate a CUTS personal vehicle. This is in the range of 25 to 50 cents per vehicle kilometer, as shown in this chart from the US AAA. NETS cost per vehicle kilometer would be less than 1% of CUTS. The entirely new WAN guideway cost would add less than 0.2 of a cent to the vehicle kilometer costs. The CUTS network element capital costs are largely covered by the government expenditures. There are many options to recover the NETS costs. We favor having passenger trips within a landmass being free. CUTS is very dirty, while nets would have very low environmental impact. Almost all of the nets reductions are related to the noted cost reductions. Nets would have no greenhouse gas emissions from operations, and less than 1% of CUTS emissions from asset builds and maintenance. Much of the existing direct and indirect CUTS land consumption, like parking lots and stranded building assets, can be repurposed. A net's design is specified through the course of this playlist. Enough detail is provided to convince most viewers that a net's implementation, fulfilling these claims, could be operational in any region of the world whose populations choose to deploy it by 2030. The design makes use exclusively of existing technologies. Any advances available by deployment time would largely be in the energy and storage areas. The energy costs assumed for this chart are 5 cents per kilowatt hour. It is likely that the NETS E electricity subsystem would cost less than half that with a 2028 deployment. On the potential downside, NETS implies massive reductions in direct and indirect job requirements, a democratization of profit mechanisms, and the stranding of major assets like CUTS vehicles. We identified these throughout the playlist as the appropriate details of the NETS design are revealed. There are multiple ways NETS, as a basis for change, would address these issues. NETS provides a large quantitative advantage over CUTS in each metric area, but there is also a qualitative advantage for NETS over CUTS in terms of safety and decisions about taking or not taking particular trips for both people and goods. For safety, no longer would we need to teach our children how to be safe with traffic. NETS has learned to be safe for all passengers and third parties. With NETS, any person can choose to take any trip starting at any time, including their present. For goods, they can request a trip with pickup after and target arrival times. Either type of trip may be to any location reachable by the NETS network. The NETS network is a superset of the CUTS one. The time and cost of the trip would not vary significantly based on the departure time. For trips within a landmass, passenger fees could be $0. As an example, consider that your family and a few others would like to go out for dinner, a show or sporting event, and potentially some post-event activity. Today, all travel to the dinner site and after uses CUTS. This generally means that all parties must reside in the same settlement. Consider groups that come from the Toronto, Boston, and DC areas and are meeting in New York. All groups can leave at different times, and even the furthest would take less than 90 minutes from door-to-door departure and arrival. For a 7 p.m. reservation, the Toronto area group could leave as late as 5:30 and still arrive by 7. Even a 2 a.m. return would take the same time and be quite comfortable. There need be no cost for any of the travel. Both the travel times and the costs make this scenario impossible with CUTS. NETS enables fractional cent costs and sub-minute delivery or pickup of arbitrary items shipped inside NETS reusable boxes. Fine-grained services could exploit these to provide services for many functions like dish cleaning to per-use rental of items ranging from clothing through all meal-related functions and household maintenance tasks to hobby equipment. Goods manufacturing demand related to devices that provide such functions today could decrease by more than an order of magnitude in many cases. Household expenditures on objects used for these tasks today could see similar reductions, but that also leads to even greater labor demand reductions than those in transport and transport energy areas. Further, ownership of these services would be mostly at the household level. This is what I referred to as the democratization of profits. Many of today's mental and physical tasks performed in job contexts today are rapidly becoming automatable by AI and AI-based robotics. This will happen independent of NETS. The total job losses from AI alone could be less than with the NETS-based effects. However, there would be corresponding increase in profit potential for the owners of the automated capital assets. This is one of the main influences on increasing inequality around the world. Some government response will be needed, even for this milder case. We believe that we should promote a world in which no one needs a job to provide a quality of life better than that available to well-to-do retired people today. In subsequent video series, we specify how our water, meal, shelter, and other functions could be provided without requiring most labor. We preview this in a summary video of this series. In this, and the following videos in the playlist, we know that we do a poor job as a messenger. We know the presentation of the content is subpar. We welcome anyone who would be willing to improve these videos or provide their own perspective on nets in their channel. This assumes individuals who have been convinced of the claims made here and the need to address the coming world with minimal need for human labor and better qualities of life for all. A link can be found in the description to contact us if you are interested in such a collaboration. Such collaborations would be the first of many to lead to an operational nets deployment. These would include the political side of educating people of the advantages of a basis for change world built assuming nets.